All right, let's talk about something every TypeScript developer does, probably without even thinking about it. But what if I told you that one of those tiny, everyday choices could actually be a ticking performance time bomb buried deep inside your code base? Yep, we're talking about this classic question: type or interface? When you're defining an object's shape, which one do you reach for? For a long time, the general advice was kinda, it doesn't really matter, just pick one and be consistent. Well, it turns out it can matter. A lot. Because this simple choice, this thing you might decide on a whim, can have a truly massive hidden cost. And I'm not talking about a little bit of lag. I'm talking about the kind of cost that can bring an entire project to a grinding halt.
So let's be real. Why do so many of us lean towards using type? Well, it's all about that developer experience, right? It feels good. When you use a type alias and you hover over it in your editor, you get this beautiful, fully expanded view of the whole object structure. It's instant clarity. With an interface, on the other hand, a lot of the time you just see its name. So you can see why type feels like the more helpful choice in the moment.
But here's the twist. That very same convenience, that awesome instant clarity, is exactly what led one development team straight into what they could only describe as performance hell. So what does performance hell actually feel like? Well, as their project got bigger, the symptoms just started piling up. Their code editor slowed to a crawl, just painfully slow. Their laptops sounded like they were about to take off, with the CPU humming constantly, just from them typing. And the real kicker? The very type information that type is supposed to give you, it just stopped showing up on Hover. It all got so bad that a critical development branch was totally blocked. Nobody could merge their work. Everything just stopped.
Now, to put this into perspective, their normal build time in their deployment pipeline was around 1 minute. Pretty standard, right? Totally reasonable.
And then, almost out of nowhere, that build time exploded. We're talking over 30 minutes. 30 for every single commit. Can you even imagine your entire pipeline getting 30 times slower? This wasn't just a minor issue. The project was becoming impossible to work on. So the team was just completely baffled. They spent a whole week pulling their hair out, trying everything you can think of, tweaking compiler settings, rolling back libraries, you name it. Nothing worked. So finally, out of pure desperation, they decided to test a really wild hypothesis. And what they found was that the culprit, the source of all this pain, was hiding in plain sight the entire time. It was their project-wide, consistent use of type aliases for defining objects. So they ran an experiment, a global search and replace, changing all their object types to interfaces. And the result? The editor lag, gone. The build times dropped right back down to 1 minute, instantly. Okay, that is a crazy story, but it leaves us with the million-dollar question: why? Why in the world is interface so much faster in these situations? It all boils down to two key concepts: eager versus lazy evaluation. You see, a type is just an alias, so when the compiler sees it, it immediately does all the work to figure out and expand the final concrete shape. That's eager evaluation. It does the heavy lifting up front. An interface, on the other hand, creates a new named type. The compiler just sees the name and says, got it. It doesn't bother calculating the full structure until it absolutely has to, like when you actually try to access a property. That's lazy evaluation. So type pays the performance cost immediately, while interface defers it. And hey, don't just take my word for it. This isn't just some one-off story from a single team. This is a known, documented behavior. The official TypeScript documentation itself says, and I quote, "Using interfaces with extends can often be more performant for the compiler than type aliases with intersections." So it's straight from the source. Okay, so the natural next question is, should we just, throw type in the trash and never use it again? And the answer to that is a hard no. Absolutely not. See, type isn't the villain here. It was just being used for the wrong job. Type is an absolutely essential tool for a bunch of things that interface simply can't do. You absolutely need type for things like union types, when a value can be success or error. You need it for tuple types, for when you have a fixed length array. And it's critical for any kind of advanced type manipulation with mapped types, or even just for giving a simple readable name to a primitive, like making a user ID type that's really a string. So all of this really boils down to a super simple two-step golden rule that you can start using right now. Step 1, if you are defining the shape of an object, think component props, API data, anything with keys and values, always start with an interface. Always. Step 2, for literally everything else, unions, tuples, all those fancy type manipulations, that is the job for type. So you see, they're not really interchangeable at all. They're two different tools for two very different jobs. An interface is your go-to for efficiently describing the shape of objects, and a type is your powerful tool for aliasing and manipulating types in all sorts of other complex ways. Once you see it like that, the choice becomes pretty clear. So the real takeaway here is that a tiny, seemingly harmless decision, when repeated over and over in a growing project, can have huge, unexpected consequences. Which kind of makes you wonder, doesn't it? Is your codebase hiding its own little performance time bomb, just waiting for the project to get a little bigger? That's something to think about. Thanks for joining me.